All right, so we've been looking at a lot of skills that are specific to polynomials. After all, they're in Chapter 5, the Polynomial Chapter, and it's a lot of stuff involving square roots and imaginary and complex numbers. And one of the reasons that we're doing that is because those are the kinds of tools that are essential when you're breaking down polynomial type problems. Um, right now, we're just in the learning the skills portion of it. However, we will be getting to chapters later that have fairly complicated polynomials and polynomial problems in them, and we want to make sure that we are well acquainted with these skills before we get there. But in order to kind of wrap up all these skills and, put a nice bow on it, what I want to do is show you a variety of, well, really it's one kind of problem, but it's in a bunch of different cases where these skills become important. And it's going to be specifically in the context of the quadratic formula. Please tell me you all remember the quadratic formula. We math teachers work so hard to make sure that you learn it. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac over 2a. First of all, because this is a bit of an unusual view, can I just confirm that you can read this? Can I get a thumbs up or something? Okay, good. I got some thumbs up. That's what I wanted to see. So you're able to read that. That's the quadratic formula. Now, because our last couple sections were about how to handle radicals and square roots, but also how to deal with complex and imaginary numbers, this square root right here is kind of where the show is. And there is this quantity underneath the square root that is really important here. I just want to make good use of my paper, but also my space, so I'm going to move that up just a bit. It's called the discriminant. Okay? The discriminant is this quantity b squared minus 4ac. And the reason why it's so important is because this is what determines whether the quadratic formula is going to be a pain or whether this is going to be an easy problem. Let me show you what I mean. There's 5 different ways that this could play out, and they all have different consequences graphically. So here's one possibility. I'm going to call this case 1. In case 1, b squared equals 4ac. And that means b squared minus 4ac equals 0. And when that happens, this becomes very easy, right? It's just going to be opposite of b plus or minus the square root of nothing over 2a. Well, since the square root of 0 is 0, then we can just kiss all that goodbye. And that's the whole answer. Notice it's only one answer. The plus or minus doesn't matter anymore. Usually, when you do the quadratic formula, you're used to getting 2 answers. But when b squared is equal to 4ac, you only get 1. So, in order to make this work, we just need to come up with the equation for some parabola where it is the case that b squared equals 4ac. And I can do that for you if, say, a equals 1, b equals 6, and c equals 9. Then it will be the case that b squared equals 4ac. If b is 6, 6 squared is 36. 4ac would be 4 times 1 times 9. That's also 36. So let's see what a parabola looks like. 1, 6, and 9. Let me just go there and enter in those numbers. So x squared plus 6x plus 9. And look at that. There's only one x-intercept. You see how that works? If you had to do the quadratic formula on this parabola, it would be your lucky day, because you don't have to deal with any complicated math here. It's just the square root of 0. It's gone. You see? Okay, well, you can't be that lucky all the time, so there are other cases. So let me get another sheet of paper and let's go through case 2. If this is looking complicated and difficult to follow, these notes are already written out. They're in Google Classroom for you, so don't worry if you miss something. I do have 5 cases to go through. They are a little complicated, so I may not be able to linger on it as long as you might like. All right, so case number 1 was when there was only one solution. Case number 2 is going to have 2 solutions, but it's still not going to be that difficult. So here's what case 2 looks like. Case 2 is where the discriminant b squared minus 4ac is a perfect square. When b squared minus 4ac is a perfect square, then when you take the square root of it, there's no drama, right? So a good example of something like that would be just say, well, here, let's start with what we had before. A equals 1, b equals 6. But this time I want there to be a perfect square left over. So if I let c equal 8, then b squared minus 4ac will be b squared minus 4ac. 4 times 1 times 8 is 32. So this is 36 minus 32. That's equal to 4. And 4 is a perfect square, isn't it? When you do the quadratic formula on that parabola, you're going to end up with opposite of b plus or minus the square root of b squared minus 4ac. There's 2a. See? It's a square root of 4. No drama. Everything's fine and easy. It's just going to be minus 6 plus or minus 2 over 2, which, reduces to negative 3 plus or minus 1. So that's minus 4 and minus 2. But you don't have to take my word for it. Let's have a look at it. Let's go back to this parabola. Right now, when b squared perfectly equals 4ac, you only have 1 point there. But let me change this 9 to an 8. All of a sudden, 1, 2. Do you see how that happened? It's not magic. It's just that when you change that last number so that there is a perfect square left over underneath that square root, okay, there's a perfect square left over under that square root, then you get 2 no-nonsense whole number answers. So I think we can agree that case 1 and case 2 are our favorite cases. These are the ones that we give to 8th graders when they're learning the quadratic formula for the first time. Just get a whole number answer or 2 whole number answers, and that doesn't break their 8th grade brain. But you guys aren't 8th graders. And so that's why we're going to move on to case 3. So case 3 is where you're going to have, hold on, I need to make sure that I'm actually following the notes because I don't want to get out of order. I'm going to have the same case 3 here that I have in the notes. Oh, good. Good. All right, so, yeah, case 3, we're not going to have whole number answers. So for case 3, b squared minus 4ac is not a perfect square. And this is the beginning of many sorrows, because this is when you have to have an irrational answer. But never fear, you know how to handle this now. We just did a couple sections on this, so no need to fear. So let's just change the numbers again so that b squared minus 4ac isn't a perfect square. If we were to do something like a equals 1, b equals 6, and c equals 7, then b squared would be 6 squared minus 4ac. 4 times 1 times 7 is 28. So we're looking at 36 minus 28. That's not a perfect square. That's 8. And so when you fill in the quadratic formula with those three numbers, you end up with opposite of b plus or minus the square root of b squared minus 4ac over 2a. Ugh. So that makes the 8th grader upset, but you guys can handle that because we know how to deal with that now. When you're trying to simplify a square root, you look for a factor of this that is a perfect square. Does 8 have any factors that are a perfect square? Well, sure, it's the same one from up here. 8 is divisible by 4, which means this thing is equal to minus 6 plus or minus the square root of 4 times 2. Now that is going to be possible, okay? You factor out that square root of 4, and it just turns into a 2 outside of the square root, like this. Minus 6. Oh, that's not even a minus. Here, I'll just let that be the fraction line. Minus 6 plus or minus 2 times the square root of 2 over 2. You see where it's going? If you take that square root of 8, factor the 4 out inside the square root, then that becomes a 2 outside the square root, and all of a sudden I've got even numbers on the top and on the bottom. Cancel a 2 out everywhere. Here's what you end up with. Negative 3 plus or minus the square root of 2. That right there is how you need to leave it, because if you were to get, sorry, the minus sign's not visible. If you were to get a decimal approximation for the square root of 2, it's no longer exact, and that makes the math teacher sad. So we're just going to leave it as minus 3 plus or minus the square root of 2. Let's see that. Let's see that in the graph. So if I change this 8 to a 7, here's my two solutions, and they're both irrational. You see? They're two irrational solutions. So our choices are one solution, two whole number solutions, or two irrational solutions. When it's just one solution or two whole number solutions, you can do that with Algebra 1. But as soon as it turns into two irrational solutions, you got to break out the Algebra 2 to solve that. I said there were 5 cases. We've only done 3. So we're going to have to move on to the next 2. Okay. So you'll notice I was moving this parabola around by only changing c. I'm trying to not overcomplicate it. So I'm going to keep only changing c. But here's case 4. Case 4 is where b squared is less than 4ac. Okay, we started out with b squared equal to 4ac. Then we had b squared greater than 4ac, because when you subtract it, you get something left over. But now b squared is less than 4ac. When b squared is less than 4ac, it means that b squared minus 4ac is negative. And when it's negative and you take the square root, you get an imaginary number. Okay. Well, if b squared minus 4ac is less than 0, but the absolute value is a perfect square, then we only have one kind of difficulty to deal with. So let's go ahead and do an example. If a equals 1, b equals 6, and c equals 10, then b squared minus 4ac is going to be 36 minus 40. 36 minus 40 is negative 4. Now, it's negative, but 4 is a perfect square, right? It means that negative 4 is also a perfect square of an imaginary number, namely 2i. When you put this in the quadratic formula, it looks like this. Opposite of b plus or minus the square root of b squared minus 4ac over 2a. That looks just like case 2, except that's negative now. When you simplify it, negative 4 turns into 2i. You've got minus 6 plus or minus 2i over 2. Everything's even, the 2's cancel out, and you've got minus 3 plus or minus I. So usually when we think about imaginary answers, we think of them as impossible. But there's nothing impossible about this parabola, a squared plus 6x plus 10. Did I say a squared? I meant x squared plus 6x plus 10. In fact, let's just go graph it. Back over to Desmos. Just creep this back up. Here's 2 irrational solutions. Here's 2 rational solutions. Here's 1 solution. What's going to happen when I change this to a 10? There's no solutions. There's no real solutions, right? There's no real x-intercepts. There are 2 solutions to the quadratic formula. It's just since they're both complex, they don't have any real x-intercepts. And so any parabola that's completely above the x-axis like this, or if it were concave down, right, it would be completely below it, one that never crosses the x-axis, it only has complex solutions. But I want to make sure that I point something out to you. This function is entirely made out of real numbers. Everything in this function is a real number. And yet, I've got 2 complex solutions, and this is really, really important that, that you get this. These aren't just any 2 complex numbers. This plus or minus means that it's minus 3 plus I and minus 3 minus I. Do you remember what we call 2 complex numbers which are the same except for the plus and minus? That's the complex conjugate. So, anytime you are taking the quadratic formula to find the x intercepts, right, or the solutions to a parabola, you could have 1 real number or 2 real numbers. Your 2 real numbers could both be real, or they could both be irrational, or you could have 2 complex solutions. But if you have complex solutions, they must be conjugates. It's a requirement. Okay? You can't have a parabola with whole number coefficients where both of the solutions aren't rational, or both of them aren't irrational, or both of them aren't complex conjugates, because they're both coming from this discriminant. The only difference is this plus or minus. I said there were 5 cases. I've only done 4. There's only one more. Okay? One number, 2 rationals, 2 irrationals, 2 complex, but everything is rational, and then 2 complex where you have something irrational. So this would be case 5, the last case. Oop, here we go. Case 5 is where b squared is still less than 4ac, and b squared minus 4ac is negative, right? Still negative, but it's not a perfect square. Well, we just need an example to see how it works. If a is equal to 1, b is equal to 6, and let's let c equal 11 this time. Okay? That means that we'd be looking at a b squared minus 4ac. That would be 36 minus 44, and that's negative 8, right? So let's put that in. Opposite of b plus or minus the square root of b squared minus 4ac goes in there over 2. One of the things that I love about this is that I shouldn't really have to do this work again, because it should look pretty much exactly like that work, where the 8 splits into 2 times the square root of 2. But it's also going to look like this one, where everything was the same except an I came out, which actually sounds kind of gruesome when I say it like that. Let me simplify this. That negative 8, right, becomes the square root of negative 4 times the square root of 2 over 2. The square root of negative 4 is 2i. So I've got minus 6 plus or minus 2i root 2 over 2. The 2's cancel out, and so you've got minus 3 plus or minus I root 2. That is probably the hairiest single answer you've ever seen in a math class. Would I be correct in that assessment that that thing looks like the spider that you just noticed on the ceiling, and you're like, bleh! I don't know if that's the feeling that you're getting from that, but I just want to assure you this is nothing but all of the little manageable problems that we just went through. You're okay with irrationals, you're okay with complex. No reason why you can't be okay with them at the same time. Notice the plus or minus. These are complex conjugates. Okay? Your 2 answers are minus 3 plus or minus. I'm sorry, I just already did the plus or minus. I wanted to do them separately. Minus 3 plus I root 2 and minus 3 minus I root 2. Let's see the graph. If I change that into 11, you wouldn't know it, but this parabola has two solutions. It's got 2 complex x-intercepts, you could say. And not only are they complex, they're also irrational. Okay. So that is all 5 possibilities. You can either have, here, let me go through them one at a time. You can either have one solution. You could have 2 solutions. You could have 2 irrational solutions. Or you could have 2 complex solutions. Or you could have, 2 complex and irrational solutions. The real solutions will always be at or below the x-axis, so it needs to cross them. The complex ones will always be away from the axis and they won't cross it. As for whether it's rational or irrational, it all depends on whether b squared minus 4ac is a perfect square. Okay, well, that's that.